So guys, welcome back. Now let us get ourselves familiar with physical pages and physical frames. So shown in the diagram on the left hand side is a typical RAM. Let us say that it is the main memory whose size is 4 gigabytes. Therefore, the address of the last byte in this random access memory is 2 raised to the power 32 minus 1. This will be the physical address of the last byte in this physical memory. Now, if we fragment this main memory in blocks of equal size, each block is then called a frame, right? So you can see that we have logically divided this physical memory into blocks of equal size. On most system architecture, the size of the frame is taken as 4 kilobytes, right? So this is one frame and the size of one frame is 4 kilobytes. This size is configurable and you can change it, but the operating system designers have chosen 4 kilobytes as the most optimal value to be used as a size of a frame. So now the question is, how many frames are there in this 4 GB of physical memory? Just apply a simple mathematics and you will get that number of frames will be equal to size of physical memory divided by size of one frame. So it means that this 4 GB of physical memory is divided into 2 raised to the power 20 frames of equal size. Now coming to the physical page. The snapshot of the data stored in a frame of a physical memory is called a physical page, right? So frame of a physical memory is nothing but it is a block of physical memory of size 4 kilobytes. And of course it's a physical memory, therefore you will have some data over here, right? Now if you pick up a camera and take the picture or snapshot of this frame of this physical memory, then what you will get is the snapshot of the data which is stored in this portion of the physical memory. That snapshot is called physical page. So obviously the size of the physical page is equal to the size of a frame of physical memory. So you can always think the physical memory frames as container of physical pages. So the important takeaway from this slide is that a physical page is nothing but it is a snapshot of one of the frame of the physical memory. So you can understand it better with the help of an analogy. So analogy here is that suppose you have a container and inside that container you can keep maximum of 3 apples, right? And your target is that you have to carry 9 apples from one place to another. So what will you do? You will take a container, you will put 3 apples inside that container, you will then transport those 3 apples from your current position to new position. You will come back with the empty container because you have taken out those 3 apples at your destination spot. Again you will place the next 3 apples in the container and again transport those 3 apples to your new location, and again you will come back with an empty container and you will repeat this exercise. So in this analogy, your container is like a main memory which has maximum of 2 raised to the power 20 frames. Whereas number of physical pages existing in the system is not limited by main memory size. You can have extremely very large number of physical pages, and we will see in the next slide that only 2 raised to the power 20 physical pages can be kept in the main memory at maximum. The rest of the physical pages have to reside on a disk.